Hey everyone. So today we're going to be going over rate of change and slope. Now we've went over how to graph linear functions. We've also kind of went over how to create equations for linear functions. So today I'm going to teach you how to do it in a more mathematical way. Before, the way I had you do it was y is equal to something, your rate, times your x, plus whatever you started with. If you don't remember this, it should at least look a little bit familiar. If not, we can review it more. Essentially, what this is saying is once you've identified your y, which is your dependent variable, and once you've figured out your x, which is your independent variable, you can just figure out what's happening to each. Now, I'll go over it very quickly in this video. Essentially, your y needs your x to do anything. Your x does not need your y to do anything. So here's what I mean by that. So right here, let's look at this, right? Number of lawns mowed versus amount earned. Okay, awesome. So if you look at this, every single time we add on 2 days, okay, we get, what is that, $30? Okay, not too bad. But let's compare the variables. So we have lawns, lawns and money. I've already told this in class, money's always y. There will never be a time when money is necessary to do anything. It's just something that we want, but it's not necessarily something we need. For example, if I stopped mowing the lawns, can I charge money for that? No. I can't charge money if I'm not mowing lawns. That is stealing. That is just taking someone's money because you feel like it. No, it doesn't work. However, if I stop charging money for mowing lawns, I can still mow lawns. I can still do it. It's probably your chores, or maybe you're doing someone a favor, but you could totally mow someone's lawn for no money. So that means that the lawns doesn't care if the money's there, but the money can only happen if the lawn's there. So that means lawn is your independent, the money is your dependent. So there goes there and that goes there. So let's look at this. If I did one lawn, that means that I get $15. How did I get from here to here? Well, it looks like I just multiplied by 15. Oh, that's multiplied by 15. Okay, let's see if the trend continues. Remember, we want this to be a rule for every time. So let's see if it's true. Well, at 3 lawns, I get $45. Well, to get from 3 to 45, I also have to multiply by 15. Okay, so it seems like this is pretty good. So right now, I have y is equal to 15 times however many lawns you did, and then it doesn't look like they had any money to start with, so there's no start. You could put plus 0 if you want, but if you just wrote y equals 15 times x, that's also okay. So that's a little bit of background, a little bit of review of what we talked about on Thursday on how to create a linear equation based on information. The first things you do is decide, okay, what's my x, what's my y? Okay, cool. How did I get from my x to my y? Is it consistent every time? If so, cool, that's my rate. Did I start with anything? Nope, so there's nothing from my start. Cool. And that's it. So that's a very basic understanding of how to make it, and it requires a lot of logic and deduction, which I know that some people struggle with. So instead of using logic and deduction, this is another way to do it. This is another way that is not brainless, but it's very mathematical, and you don't have to do too much critical thinking. All you need to do is follow these steps, and that is rate of change and slope. Now, notice that this is rate of change and this says rate. That's because they are the same thing, This is your rate of change. This is your slope. The only difference is I'm going to teach you how to calculate it as opposed to just, it should be this because of this. So this is your rate of change or your slope, same thing. Mathematicians like to use different words for the same thing and is really, really inconvenient. However, it's still being used, so you still got to know it. So, rate of change, slope, this is what I'm talking about. Now, the way to do it is, there's two ways. The first way is, that is upside down. Okay, the first way is an equation way. And the equation is a little bit confusing at first, but once you start using it more and more, it'll just be like second nature. So, slope, which is also represented by the variable m. So whenever you see the letter m, that's what we're talking about. So m is equal to y2 minus y1, and I'll explain what these mean, over x2 minus x1. So this goes back to all the way when we were learning about how to draw a line. If you want to draw a line from an equation, let's say you had y equals 3x, right? We had to pick two values for x. I chose 0 and 1. So 0, so that becomes y equals 3 times 0, which is 0. Okay, cool. Y equals 3 times 1, which equals 3. Okay, awesome. Turn these into ordered pairs. And then draw them on a graph, right? See, 0, 0, 1, 3, and then draw a line through it, except you actually go through it, and then you label. I mean, you could label before, but it really does, as long as you label at some point. So that's how you were to graph it, right? But for here, if you wanted to know the slope, and let's say they only gave you ordered pairs, you're going to use at least 2 points. These same 2 points, except this time they're most likely just going to give it to you. They're not going to ask you to solve for it. They will actually just give it to you. Otherwise, this won't be possible. So the 2 points that we have here are 0, 0, and 1, 3. These are our two ordered pairs. We're now going to try to find the slope from it. Okay, the slope is our rate of change. It is how much we are changing our x by to get our y. It is this part right here. It is what are we doing to our x to get to our x to get our y. Here we're multiplying by 15 to get our y. Same thing. Now we're going to figure out, okay, what are we doing with this particular one? So here we have our two ordered pairs. It doesn't matter which one you pick, really. I'm going to make the top one ordered pair number 1. I'm going to make the bottom one ordered pair number 2. You could have flipped it. It really doesn't matter. The only thing that matters is you stay consistent. So here we have those two. Remember that our ordered pairs are x in the front, y in the back. That's how ordered pairs work. So what this is telling me to do is to take the y of my second ordered pair. Okay, so I go to my second ordered pair number 2. I find the y, that's 3. Minus the y of my first ordered pair. So the y of the first ordered pair, the y is 0. Over the x of my second ordered pair. Okay, that's second ordered pair, that's 1. Minus the x of my first ordered pair, that's 0. So that is 3 over 1, which is just 3. So that means that my m, my slope, my rate of change is 3. So I can write this as y is equal to 3x. Well, what do you know? I'm back to here. So this is now creating an equation just based off two ordered pairs. This is all you need to create an equation. You don't need anything more than that. Let's try another one. Do I have space? No, I don't. Okay, I'll make space. Keep going down. Okay, so let's look at this when it's not. So let's say, right here, they give us this line and they give us a bunch of ordered pairs. Now, we don't need all these ordered pairs. We only need 2. So I'm just going to pick 2. Oh. I'll use 460 and 230. Again, if you want to use more, go for it. You really only need 2. I wouldn't recommend doing any more than 2 because things get really confusing. So again, I'm going to assign them 1 and 2. It doesn't matter. I'm going to make the bottom one 1 this time, and I make the top one 2. Sure, it really doesn't matter. So I write out my slope equation. Y equals y2 minus y1 over x2 minus x1. And so this is saying the y of my second coordinate, okay, there's 60, minus the y of my first coordinate, so I go to first, and the y is 30, okay, over the x of my second coordinate, so I go to this one, that's 4, and I go to the minus the x of my first, so that's 2. Minus it out, I get 30 over 2, which is 15, okay, so that means that my slope is 15. That means that my equation is y is equal to 15 times x. Because remember, it's your rate times x. We didn't have anything to start with. We're not going over starts right now. We'll go over more starts on Wednesday. For now, all we're really going over is this, your m. This is the star of this lesson. That's all we're really going over. So that's the algebra way to do it. All you do is you take 2 ordered pairs that they give you. It doesn't matter which one. You assign them numbers 1 and 2. Again, doesn't matter which one. And then you plug it into this equation. Okay? If you're still having trouble with how to use this, we'll go over it. But we'll go over another way to go over it in case this is also still very difficult for you. Now, this way is very easy. It's very quick. The biggest problem with it is that it only really works if you have a graph in front of you. So for example, this is called the triangle method. So slope is thought of as rate of change. We went over that. And something that you might have learned in 7th grade, but it's really fine if you don't. I'll go over it now. But the rate of change, I'm just going to put ROC. The rate of change is equal to y over x. So once you establish your y and your x, that's it. That's just y over x. You just divide the two. Now, y in graphing is your up and down movement, right? This is what's known as your rise. It's your up and down. Your x is your left and right movement on the graph. Your x-axis, that's your left and right movement. This is known as your run. So your slope, which is the same as rate of change, is known as rise over run. Now, this requires a lot of background knowledge. Again, if you're not super comfortable with your background knowledge, you could either study up or maybe just not use this, which is completely fine. I'm giving you a bunch of methods on how to do it. It just depends on finding the one that's right for you. I highly recommend trying each way at least once just to see which one works best for you, and then you can make your decision. So we have that, rise over run. And the way we do that is we still take 2 points. So let's use this one, right? Let me try to recreate this. That. Then we have that. And then, what is that? What are the 2 points that they use? They have 0, 0 on there. Cool. So I don't have to worry about that too much. And the other one they have is, what is that? 1, 2, 3, 1. Cool. 1, 2, 3, 1. All right. If only I were good at this. There we go. Cool. As you can tell, drawing is not my forte. Drawing on a computer, even less so. But thank you for bearing with me. So here we have our 2 points. Again, 2 points. Always just, if you're ever wondering what I should do, just start with 2 points. Really. For lines, especially now, 2 points. That's all you need to really care about. So what I'm going to do is I'm going to create a triangle. Now, it doesn't matter which way the triangle's going. I can either make it like that, from one point to the other. This is my triangle, like that. Or I can make my triangle like this, going the bottom way. It really doesn't matter. It really doesn't. So what I'm going to do is I'm going to just kind of see my movement. Now, if you remember on a graph, going up and going right are positive movements. So like this is up, this is all positive numbers on the y-axis. This is all positive numbers on the y-axis. And then going down and left are negative movements. So this is all negative numbers on the y-axis. This is all negative numbers on the x-axis. So in order to do this, I'm going to move up 1. So according to this, I move up 1. And then I move to the right 1, 2, 3 times. Okay. If I did the red way, I have to move to the right 3 times, and then I moved up once. So it's like the same thing, right? It really doesn't matter if you put it above or below the line. Just remember you're going from left to right. It's like reading a book. You always want to go left to right. So here, according to our red triangle, our run, our left and right movement, we went to the right 3 times. Therefore, it's positive movement, so positive 3. And then we went up once. That means our slope is 1/3. Okay. That was pretty easy. We didn't have to do any calculations really. All we did was we made a triangle. We counted how many movements and where the movements were going, and then we plugged them in. So let's try another one. So let's say I got this, and then that, and then here we got 2 points. I don't know. What is that? That's a 0, -5. So 1, 2, 3, 4, 5. And then this is, what is that? 1, 2, 1. So that's 1, 2, 3. So that's -1, -3. Something like that. Cool. Make a line through it. Do the thing. And then do the thing. Cool. So again, I'm going to make my triangle. It doesn't really matter which way I'm going. I'm going to do it in green. So I'm going to go this way and then that way. Okay. So in order to get from the leftmost point to the rightmost point, remember you always want to go left to right, left to right. So this is the leftmost point. So I had to move to the right 1 time, and then I had to move down 2 times. Okay. So a rightward movement, if I remember right, is a positive movement. So that's +1. And then I went down 2. So down is a negative movement. So -2. So if slope is rise over run, my rise, well, is -2 because I went down 2. My run is, I went to the right one, so +1. So the overall is going to be -2 for my slope. If I had to create an equation for this, this would be y is equal to -2x. And then there's a start here, but don't worry about that. We're only really worried about this right now. If you can get to this point, if you can solve for your m, you're good. So I've shown you 1, 2, 3, 4-ish methods on how to find your rate/slope. So we'll go over more of this. You can figure out which one you like best. I don't really care which one you use as long as you get it right. And we'll go over more of this on Tuesday, and I will see you then.